Hi, I'm Gareth Kane. Welcome to the Net Zero Business Podcast. Today, I am delighted to be joined by Ayah Alfawaris, who's head of group marketing and sustainability at Wilson Power Solutions Limited. And Wilson Power Solutions make transformers, not the robots in disguise, but the big grey boxes that make our electricity system work. Welcome to the podcast, Ayah.
Hi Gareth, how are you?
I'm good. I'm good. I'm really looking forward to getting into this because I think this appeals to my nerdishness. But before we go into the technical bits, how did you get started in sustainability?
So originally I'm from Jordan. I grew up in Jordan, and growing up, I stumbled upon this sort of statistics that was like 98% of our energy is imported in the country, and that was like a huge shock that we do not produce our own electricity. So that got me into sort of activism, and then I got a job in solar energy. I had done like a degree in engineering, so it was an easy sort of transition for me. But yeah, I started with solar energy, worked in the region for a bit, and then moved to the UK to do masters in sustainability and business at the University of Leeds. Because I was just interested in sustainability altogether, and that's where like all the critical thinking came about, and what greenwashing is, and carbon neutral, and what we should and should not do, um, and from then on, I sort of continued my work within the energy sector. So worked with a company that did gas peaking plants, and then after that moved to Wilson Power Solutions, where we manufacture transformers. Now, transformers, some people would not necessarily link them to sustainability, but they are sort of at the core of enabling sustainability. But obviously, for us as a business as well, we have our own sustainability targets, if you will.
Yeah, fantastic. And let's start with the transformers. Now, I'm an electrical engineer as well, so I don't know as much as I should probably, but I know a bit about it. But just if anybody's coming to this as a layperson, what does a transformer do?
So transformers are key pieces of infrastructure. They sit on the electrical network, and they step the voltages up and down.
Mhm.
They work on the electromagnetic induction of sort of the theory of, Faraday's theory of electromagnetic induction, and they help us do a lot of things. One of them is they sit on the transmission and distribution networks that allows us to sort of send energy or current throughout the network without losing a lot of electricity in the way, but also allow us to sort of control the voltage levels where we want to use it. So at a home, we'd step down the voltage to a safe level for consumers to use it at.
Yeah, I think I read somewhere recently that if we didn't have transformers in the system, we wouldn't get any energy out. It would all be lost in transition.
That is
Uh,
correct.
Yeah, so they are essential, and I think you, if you don't mind me saying, mentioned you called them unsexy when we were putting emails backwards and forwards, but they may be,
Not to me.
yeah, but they are absolutely essential. Obviously, we're seeing this big push now for electrification, whether it's connecting renewables, whether it's charging electric vehicles, heat pumps, battery energy uh, storage systems. When are new transformers needed in each of these? Because obviously you can, you can plug in your EV at home, but when do you need a transformer
Yeah.
in an EV charging system?
So, if we take EVs, for example, oftentimes you'd find them where you'd have public EV charging, where you would need, for example, 11 kV connection to allow for a significant capacity of power to charge multiple sort of charging points. So you might see sort of, the new charging stations at some hotels, or the completely sort of like the forecourts that GridServe, for example, build. For these, we would provide transformers because the capacity is quite big, but also the connection point that they would have on the grid might be an 11 kV connection point, a 33 kV connection point, and they would need a transformer to step down the voltages to what the charging points are at.
Yeah. And looking through a lot of your projects, it seem to be quite a few battery storage
Yes.
systems on there.
Yeah, it's a huge growth for us as a company, but also for the UK market as well. And I would say proudly, the UK market sort of was ahead of the European market in this regard, where we connected sort of some of the biggest projects really in the region. Within the battery energy storage systems, depending on the setup that they have, some batteries would have internally PCS or power conversion systems within them. That means the electricity that comes out is AC. And then
Yeah.
you can just plug in a transformer to that battery to, let's say, take it from 480 volt or 690 volt up to 33 kV 33 kV, for example. So what you'd have is you'd have multiple batteries in a site. You'd have a transformer connected to either each battery, or sometimes you can do 2 or 4 battery packs connected to one transformer to sort of improve your economics really and modularity. And then all these transformers then connect to a grid transformer. So all those little ones, we call them MV transformers, so they're like medium voltages, whereas the grid transformer takes all that power and then sends it out to the grid. So you have multiple sort of transformer setups on this. You have MV transformers, grid transformers, but also you might have earthing transformers to make sure you don't have sort of, there's a way to the ground if there's a fault on the system, but also you might have auxiliary transformers where they can do the balance of plants to, turn on the CCTV and electricity and stuff like that. There's quite a bit of transformers, and I was chatting to someone actually yesterday about this, and I think for battery energy storage systems, transformers costs within the project make up nearly 10% of the project costs, which is quite significant.
Yeah.
But obviously, without them, you will not have battery storage. You just cannot, send the current or the voltages at the right levels without transformers, really.
Yeah. And I was just thinking there because just up the road from my house, there's a substation with a transformer in it, which takes
Yeah.
the high voltage power and puts it down to our 240 level for the house. But some of my neighbors have heat pumps, some of them have EVs. At what point are we going to have to start adding to the current transformers in the system? Just because, if everybody gets a heat pump,
Yeah.
if everybody has an EV in their driveway,
It
is
is,
there
it is,
a
it is a bit interesting. Like topologies are all changing because historically, you'd add more transformers at the generation sort of side, whereas nowadays we've got decentralized generation. So as you said, there's more happening. I'm not sure you'd see transformers within houses
Yeah.
but what you would do is you'd have bigger transformers. So instead of having, let's say, 1,000 kVA transformer, that development might say. We need 2,000 kVA transformer or 3,000 kVA transformers to allow that. Now, all the sort of houses that you would have, most of them, I'd say the majority would be single phase, houses. They wouldn't have 3-phase connection. If you get to the 3-phase connection and you have, I don't know, a mansion, you might need your own transformer. But yeah.
Yeah, it would be get very large. And are you seeing demand
Yes.
rising?
Oh, massively. So I think for us as a country, and even just not just the UK, but the world, we'd need, at least for the UK, we'd need hundreds of thousands of transformers to get to to deliver really net zero if we want to deliver it, because we're talking about huge electrification. Not just adding solar, wind, and battery storage, but also you're talking about the electrification of transport, which is a massive, massive sink of, or massive opportunity, actually, if I may say, for expansion for the grid. That's one thing. The other thing about transformers is the aging infrastructure that we have. We have one of the sort of oldest, most reliable infrastructures, but it is aging, and replacing all those transformers is a huge opportunity as well. And we have been working on it for quite a few years now. So yeah, demand for us is huge. It is pushing, depending obviously on the voltage levels you talk about. So if we're talking about 11 kV transformers, we're quite in a lucky position. We've got, I think, a stock of nearly 600 transformers at any point. So we're sort of good in that regard. But when we start talking about the power transformers, so 33 kV, 66, 132, up to 400, all of these transformers tend to be bespoke designs. So it's something that you cannot stock. There's a lot of differences that just, if you change the impedance, if you change the K factor, if you change a lot of small things in the transformer, change the design completely. So that means we have to manufacture them when the order comes according
Yeah.
to the specification. But then what that did, especially for the what we call extra high voltage levels, so 275 kV or 400 kV, so that's transmission level, national grid level. For those transformers, you're talking about lead times between 2 to 3 years. Some companies offer 4 years of lead time. So it's yeah, there are a few sort of issues within the supply chain at the moment because of the huge demand that we have.
Yeah. Do you see more standardization? Is there scope for that of saying, no, design your system to fit the transformer so we can give you one in 6 to 12 months rather than 3 to 4 years?
Yeah. So it's easy when you work with the same customers,
Yeah.
then you'd see sort of patterns and you'd know what sort of bushings you'd get, what on-load tap changes you would get. And you can stock these because even the components, the supply chain that we have for us, it has like long lead times as well. So within the same customer, you can do that, but it's quite different. We keep pushing for it, but it's different for them because every battery energy storage site or solar site are different, depending on how big it is, what the local grid connection point is, how much money they can make from it, all that sort of stuff that just mean a lot of these sites are very different.
Yeah.
Not to mention the technology that you have, like you might have different batteries on there, different inverters for the solar systems, different wind turbines, etc. So it's not straightforward. We'd love to see more standardization, but I'm not sure it will happen anytime soon.
Yeah. And you have manufacturing capacity in India. Is that because of demand there, or is that just the most cost-effective place to make transformers?
Well, yeah, so it's both really. So we've got our own we have our own factory in India. It does supply a fair bit to the Indian market because it's another growing market and it's making sort of really good revenues. But on the other hand, making transformers people probably don't know that, but it's a very manual process. You need a lot of people to make transformers. It's not a machine that just does the work on itself. You need people working on these machines, experts and engineers. And we have a huge skill gap in the market in the UK. That's one thing, not to mention that if we were to manufacture end to end in the UK, transformers would just cost a lot more.
Yeah.
And I'm not sure the market is prepared to pay that price when, we've got different priorities with decarbonisation. So it's how do you balance it? Yeah.
Yeah. It was just interesting you said there was a skills gap because, if you pick up the paper, it claims that net zero is going to destroy the economy. And yet every single person I speak to says we can't get enough people with the right skills.
No, we cannot.
Okay.
We cannot. When I joined the business, so when I joined Wilson Power Solutions, that was nearly 7 years ago, we had like 40 odd people in the UK, maybe 43 people. And now we've got nearly 150 and we're still hiring and we cannot find enough people. And the other tricky part to it is not just that we've got a lot of really good staff members, but they're sort of close to their retirement. So it's a lot of sort of skills that we're losing, really. We're not transferring into people. So we started sort of an apprenticeship program recently. But also on the other hand is getting someone from like even a graduate level to train them, to get them to a point where they can work independently. I think for a design engineer, just electrical design engineer, it takes anything between 5 to 6 years for them to get to a point where they can do it independently. Same thing with site teams, so site services or installation teams. It can for extra high voltage, it takes anything between like 5 to 8 years to get someone to a position that they know what they're doing. So it's not like this. It takes a lot of time to get people up to speed, and we are struggling with it, and we are working with sort of member trade associations, and we sort of try to attract talent from outside of the UK as well if we can. Because it just as well transfers. So sometimes what we do actually, we bring some of our own staff from India to come to here, train our staff here, so they sort of they come up to speed with things. Yeah.
Yes. I'm just wondering if, going back to whether or not transformers are sexy enough, do people count people manufacturing transformers as green jobs? Just because
Yeah.
they may not be sort of bolting solar panels to roofs, but it's just as important part of the chain?
100%. I personally think it is part of the green transition because how do you connect any of these solar battery? Yeah, that's why I called it unsexy because whenever people think about decarbonization or sustainability, they immediately think about, solar panels and wind turbines, and we do need more of them, but also you need transformers to connect them to the grid. So, what is the point of, having them without being able to connect them? So it is pivotal to the transition. That's one thing. The other thing that probably one thing that we talked about the aging infrastructure in the UK, and I did ask Ofgem recently in a Freedom of Information request about the average age of a distribution transformer in the UK, and they said it was 34 years old. So what we're saying basically is that the average transformer on the network is coming towards the end of life and needs replacing. And you're talking about, I think it was nearly 240,000 transformers of that level. So, even having the skill set to replace those and to have the skill set to connect new sites, it's just, there's a lot that's happening really and needs attention, maybe from government, but also, from private companies as well, because that's only on the DNO sites. That's not the private transformers that are owned. So there's huge potential that we have, yeah.
Yeah. And that again sometimes gets because the government's recently announced a big investment in the grid, which is presumably will include that. And that sometimes gets blamed as the cost of net zero, but we'd have to replace a lot of that anyway from what you're saying, just a natural.
Yes. Well, mostly it's not necessarily just because they're coming towards the end of life. So not a lot like a decade ago, we asked the same question to Ofgem, and they said that the average age of a distribution transformer in the network was 63 years. So we're talking about transformers that remain on the network for double their design life or triple their design life, which is a testament to good engineering.
Yeah.
But the missing piece there is that energy losses on these transformers are absolutely massive. So when we talk about Europe, and the UK as part of Europe, you're talking about 2.9% of the energy lost on the network is due to distribution transformers. Now, it's a small percentage, but if you try to quantify it, it's 93.4 terawatt hours a year. So that could power Denmark for 3 years. That's the amount of energy we're sort of wasting because we have transformers that are just not efficient.
Yeah.
The regulation for efficient transformers only started into 2015. So anything that was installed before that is just an inefficient transformer. So there's a huge potential there. And sometimes when you think about it, do I put more solar panels and then lose that energy into an inefficient network?
Yeah.
So prioritization obviously needs to be sort of a thing for the government, but I'm not sure they think about transformers. That's the whole idea of probably talking to you today, is just because they're unsexy. People don't think about them. They're just wasting. We call them silent energy guzzlers. They just waste energy.
Yeah.
Sat there, and because of the amount of energy that goes through them, it's massive amounts of energy, but just no one thinks about it.
Yeah, well, that's I think the marmalade dropper for me so far is that I didn't know 3 times the consumption of Denmark. That's quite extraordinary. Are there any other limiting factors on the sector? Because there have been concerns about things like the supply of copper and things like that. Do raw materials become an issue, or does that work okay?
Well, yes and no. So the prices of raw materials is not very, it's volatile and it changes, and that changes. And because of the, when you talk about solar or battery energy storage sites, they start sort of asking for quotes for transformers maybe 2 years before the connection date or 3 years before the connection date. So we have to sort of lock a price in there before we can even build the transformer. But the copper and so one of actually the biggest struggles we've got is with the steel within transformers. So the core is usually made of what we call CRGO, which is cold rolled grain oriented steel. And that steel, there are only a few manufacturers in the world that makes that sort of grade of steel. Some of them are in China, or probably the majority of them are in China. But then we're competing with the EV industry because making cars as well, they need the same sort of resources. So we're not just competing, within the same industry and different countries, we're competing with different industries on the same resources. So yeah, you'd find that with transformers, I would say for copper and winding, copper and aluminium. So the winding of the transformer is made of either copper or aluminium. We're seeing more aluminium nowadays because it's cheaper and more available. But when you talk about the grid transformer levels, they're always copper. So they're significantly more expensive, but also harder to source. Yeah.
Yeah, so that's definitely one to watch. Obviously, as well as being a marketing manager, I said you were a sustainability manager as well at Wilson.
Yes.
So, what targets have you set for the company?
Actually, we've got a workshop tomorrow about that. So we have been talking about it for quite a while. Probably online, we don't publish a lot because I'm sort of very conscious of, I don't want to shout about things that we haven't done yet.
Yeah.
We have done quite a bit, internally, like in terms of, we've got our own solar generation. We buy renewable energy for one of the sites that we have. The site in India has just sustainability at the core. So I just came back from India last week and we're building a sort of state-of-the-art new manufacturing facility. We started the trial run in December. In there you have all sorts, like you have a lot of sort of green or greenery within that. I think it has to be like 3% of the site that you have, but also we have solar panels, etc. In the UK, we've got all sorts of sensors wherever you go, recycling. We've got a zero waste to landfill policy, but there's still a lot to do really. And we are probably tomorrow will 100% go towards the Science-Based Targets Initiative route. We've been talking about it for quite a while now. For us, what's tricky is that we as a business want to decarbonize. We want to completely maybe don't like to use carbon neutral, but go net zero where we can. The thing is we're reliant on the supply chain. So, all the shipping, which is a huge part of what we do as well. We talk about trucks, you talk about ships, it's not a decarbonized industry yet, so we're reliant on them really to decarbonize. But I think for us, it's knowing that we help others decarbonize and we enable the green transition, but also we have a transformer. So it's one product that is the most efficient distribution transformer across Europe. Quite proud of that. We do, we did, quite a bit of R&D over the past. I think we launched the first version of it maybe I think 15 years ago. But so basically what we do, we go to universities, hospitals, supermarkets, retailers, etc., and we show them the energy savings that they would get from replacing an old transformer with this sort of, we call it ultimate low loss transformer. So it's what we do internally, but also what we do with other companies really to help them decarbonize. Another interesting thing about transformers, probably a lot of people that don't know, I have a lot of customers that ask about sort of embodied carbon of transformers. And interestingly, obviously every product is different, but with transformers, embodied carbon is only 5% of the life cycle assessment of a transformer.
Right.
So it's more about how you run your transformer, the energy that goes through it, the waste of that transformer, how you maintain it, etc. That really matters. That's like the 95% chunk of it, really.
Yeah.
And another good thing about transformers, they are almost 98% recyclable.
Yeah.
So everything, copper,
yeah.
steel, aluminium. I think the only thing that even the oil, you can recycle it or reuse it somehow. The one thing that you cannot recycle is the paper insulation that you have within sort of the windings, because it would be soaked in oil over the years. It's probably the only thing that you cannot recycle.
Yeah. I was just thinking there when you're pitching your transformer, your very efficient transformer, again to people who already have a transformer in place, and we were talking about life cycles, does a more efficient transformer kind of shorten the economic life of the existing stock distributed around the country, because the capital costs then become
100%. We're talking about like a payback period of 2 to 3 years. It's
Yeah.
not, it's quite, it's a no-brainer. When one sort of engineer from the University of Warwick, when he learned about it, he just said it's a no-brainer. And, almost all transformers that they have on the network now are low loss sort of transformers. So, yeah, it's more of like an educational piece, people knowing what they have on the network, where they need to prioritize, because it's much cheaper to replace a transformer than install maybe the equivalent would be like a 60 kilowatt peak of solar.
Yeah.
So it's yeah, just priorities and money.
Yeah. And if it's only 5% of carbon as well, it sounds, even with the sort of rough back of fag packet calculation in my head, it sounds as if replacing a transformer makes plenty of sense from a carbon point of view.
Oh, 100%, 100%, yeah.
Yeah. Right. And so yeah, we've talked about a few of the challenges. What are you most proud of in what you've
Um,
achieved at Wilson? Yeah.
I would say probably mostly it's getting people excited about transformers. We work with a huge sort of variety of customers and industries, and a lot of them, for a lot of them, transformers, are like an afterthought, really. I think over the years we've managed to do quite a bit of awareness, but also do a lot of like CPD, so like educating people about how to specify a transformer, what you need to think about from day one. Do you have issues with inrush currents, harmonization? Yeah, harmonization, harmonics.
Yeah.
My brain. Yeah, so issues with like harmonics and inrush currents over voltages, under voltages, etc. And all of these are things that we can mitigate for with the design of the transformer, but
Mhm.
people don't necessarily know about them. So it's just trying to get people to understand what transformer is from a technical point of view. But also you've got a lot of new engineers that are joining the industry, and they prefer sort of online interactions, but also one of the things that I'm really proud of is our website. So what we did on the website was, okay, we're going to put a lot of educational things on there, but also technical information. A lot of companies do not like publishing their general arrangement drawings or data sheets and stuff like that. And I was like, no, we need to just put them out there, because people, are less likely to come and talk to you if they can't find the information online. Just put it online. And so it's trying to balance, what is, you don't want to lose your competitive edge, but at the
Yeah.
same time, you want to be helpful and have the information out there for people. Very, very proud of the growth that we've managed to do over the years, to be honest, getting, confidence within the market, but also getting the trust from customers and expanding the voltage levels we're working on. So yeah, a lot to be proud of, to be honest.
Fantastic. And I suppose you're far too young to ask this question. Is what are
I'm
your
not
life
that
lessons?
young.
Because I'm sure you're still on a massive learning curve. But if somebody was coming in, if you decided to pack it in, sail around the world or something, and somebody was coming in to replace you,
Yeah.
what would your advice to them be?
Um, Never stop learning, I would say.
Yeah.
I learn so much every day, and I sort of try to play dumb a lot of the time. So like I'd go, put my safety shoes on, go on the shop floor and ask the stupidest questions you would find. Because sometimes like you would understand something but not fully, especially when you talk about technical information. And understanding things fully technically is important if you're trying to, influence decisions, but also understand behaviors, change sustainability sort of impacts and stuff like that. So I'd ask, a lot of questions, never stop learning. But also another thing, I think for me personally, I wake up every day as if I was employed yesterday.
Yeah.
So like just work, do my best, trying to prove myself literally every day, and not necessarily to people. It's mostly to myself, because that's how you keep on learning and evolving really within businesses, I guess.
Absolutely, that's fantastic. Well, we've covered an awful lot of ground there. I think that was absolutely fascinating insight. And when I first came across it, I think I must have eye on because obviously you're a great communicator. You're doing wonderful things, and transformers are something of a boom industry, or will certainly will be a boom industry. So thank you for joining us and sharing that today.
Thank you for having me. Cheers.
you.